Today we're going to walk through how to make a quick sketch for the basic tangent graph of y equals 2 tangent of 1/2 x. So to guide you, on the left I have the general form of a tangent equation and the 3 steps we're going to walk through. So step 1 is to find our essentials. We really break everything down and analyze so that we can easily create this graph. All right, so start by identifying A, which is 2. That'll help us with our key points in step 2. B is the quotient in front of x. It's 1/2, and we use b to calculate the period. For tangent, that's just pi divided by b. So if you do pi divided by 1/2, it actually turns into 2 pi. It's like pi times 2 over 1. And remember, period is just the length of one cycle horizontally. So once you have the period, I like to go ahead and divide it by 4 and use that to mark the horizontal axis. So 2 pi divided by 4 is just going to be pi over 2. And let's go ahead and label that horizontal axis. All right, so we're just going to do 4 tick marks here. That'll get one full cycle, or the period. So count 1 pi over 2, 2 pi over 2 reduces to pi, 3 pi over 2, and then 4 pi over 2. This 4th tick mark to the right of the origin should always match your period when you set it up like this. So that's a great spot to just pause and double check. All right, now we're going to label our vertical axis. Look to your value for A here. Since it's 2, we'll mark our vertical axis up 2 and down 2. All right, now we're ready for step 2, where we'll plot our key points. So we always start our pattern for tangent at the origin. We start with a 0, so we'll go ahead and mark that. That's just another name for x-intercept, remember? Then you'll have your first point in the pattern. So pi over 2 is going to get its y-coordinate from that value of a. We mentioned that earlier. So we'll have a point at pi over 2, comma 2. And that's one of those curve shaping points. Move to that next horizontal tick mark and put your vertical asymptote. And then finally, you'll have your lower curve shaping point. So that'll happen at 3 pi over 2. And to get that y-coordinate, just take the opposite value for a, so -2. All right, I like to go ahead and mark, if I were to be completing another round of this pattern, I mark a 0 at 2 pi just for ease of sketching, because that's step 3. So we're going to sketch in our tangent cycle here, following along the asymptotes. And there you go. That's one cycle of this tangent graph. If you like, you can continue this pattern in both directions. Of course, you can continue with your labels as well, but I'm just going to show you, since this is a tangent graph, it's periodic or cyclical, and so you can just work either backward or forward to create as many cycles of this tangent graph as you need. All right, the last quick thing before we go, if you ever need to quickly find the asymptotes from a tangent equation, there's a great way to do this. So I'll show you briefly. Just take the inputs of your tangent function, so that's everything in the parentheses with the x, so 1/2 x, and set that equal to the asymptotes for y equals tangent x. Those are the original asymptotes for tangent x. And those happen at pi over 2 plus pi k, where k is an integer, and depending on which integer you sub in, you'll get a specific asymptote. So k is 0, 1, -1, etc. And basically, we're going to just solve for x. We're applying the transformations of our equation to the asymptotes of the original tangent graph. So basically, we're just applying this horizontal stretch to the original asymptotes, and it'll match what our graph shows. So easy enough, we just multiply everything in this equation by 2. Okay, so on the left, we have, of course, 2 times 1/2 is just 1, so an x. 2 times pi over 2 is just pi. And then 2 times pi k is 2 pi k. All right, so easy to see. If you substitute in k is 0, you get this asymptote here at x equals pi, so that's when k equals 0. If you sub in k equals -1, you would get the one here. We don't actually have it written, but that's at -pi, because you would have pi plus 2 pi times -1, which of course equals -pi. So play around with that. Sometimes it's really helpful to be able to get the asymptotes equation, and that is another great way to also check that your graph is accurate. So hopefully this method helps you get some great sketches for tangent graphs. Check the description for more links on graphing trig, and thanks for watching.